Okay, so let's take a look at question 9. We have two rectangular tanks, okay, shown below. Okay, this is the tank, and also we have this tank. Alright. At first, tank A was completely filled with water, and 1/3 of B was filled with water. Anybody can tell me, how do I find the height for tank B? And later there will be water flowing out, so I suppose the height will change. So I'm going to write original height, okay, of water in B. Okay, what will y'all do? So 1/3 multiplied by 36, because it's 1/3 of your total height here, right? Which is 36. Or another way is the 36 divided by 3, right? What you will have will be your 12 cm, okay? Which we can conclude, okay, is 12 cm. Okay, so next, what happened? Water flowed out of the tap at tank A at a rate of 1.2 liters per minute. And for B, water flowed in at the rate of 1.2 liters per minute. Okay, now this is actually very tricky because, right, if you look at this sentence, right, if you never read carefully, right, you might be doing the whole thing wrong. Can I request, right, my audience, right, can you tell me what are the important keywords that I haven't highlighted and is super important? Float out and float in. Thank you. I love your capital letter. Very and two. Yes. One is flowing out, another flowing in. Right or not? It's not both flowing in or not both flowing out. That's very, very important. What happened is they asked us for how long will it take for the height to be the same. Okay, so they are focusing in height, right, everybody? They want the height to be the same. Now, if they are focusing in height, right, I want you to also focus in the height. Instead of focusing in the volume, 1.2 liters right there, I want you to focus in the height, increase or decrease. If water is flowing out, everybody, can you tell me the height is increasing or decreasing? For A. Decrease, okay, thank you. Okay, remember here is per minute, okay? Height decrease in A in 1 minute. Alright, so what we are going to do is we take the 1.2 liters. Okay, liters not useful. Okay, why liters not useful? Because, right, cm times cm times cm is not liters. Cm times cm times cm is cm cube, right? So cm cube is more useful. So can you tell me 1.2 liter, how do you change to the cm cube first? Thank you, Xander, times 1000. Exactly, because 1 liter is 1000 cm cube, right or not? Volume is length times breadth times height. To get your height, you must take your volume. You must take your volume, do what, everybody? Divide, yes, volume divided by base area, length and breadth, right? So you have the volume here already. You need to divide it by your length and breadth. And everybody, what is your length and breadth? 20 times 30, okay? Yes. You will have 2 cm. That is your height decreasing every minute. So every time 1.2 liters of water is flowing out, your height, okay? Your height here, okay, from 40 cm, it will decrease by another 2 cm like this every minute. This is what is happening, okay, everybody? Now, remember, they asked us about the height. So I not only need to focus in the height in A, I also need to focus in the height in B, correct or not? So let's go and find out 1 minute, okay, what is the height? Now, your B water is flowing in. Flowing in means your height will increase, okay? So if the water flowing in is 1.2 liter, right, you're going to take 1.2 liter, multiply by 1000 to get how many cm cube of water there are, and then you divide it by 40 and 25. Okay, and if you do that correctly, right, 1.2 cm. Yeah, okay, so that is something we have right here. You are supposed to find out how long it will take, okay, for the height to be the same. I'm going to let the time, okay, how long it takes, I'm going to let the time be like an unknown, 1 unit, right? If you all don't know anything, usually you let it be 1 unit, right? For tank A, right, agree with me, everybody, it started at a height of 40. Then every minute, right, for A, right, it is decreasing by 2 cm. If my time taken, let's say the how long it takes, right, is in minute, okay, 1 unit minute. 1 minute, it decreased by 2 cm. What will you do to that 2 cm and that 1 unit minute? So I just give you an example. If let's say I don't know is it 1 unit or not. Let's say it was 3 minutes. What will you all do to here? If every minute, right, your height decrease by 2 cm. And let's say you know it's 3 minutes. What will you do? You will times, right? Yeah, because 1 minute, it decreased by 2 cm. Then if it's 3 minutes, right, you will take 3 times 2, right? You'll decrease by 6 cm, right? Your times are correct. But now I want you to forget about that 3 minutes because we don't know that 3 minutes, right? Doing the same approach, you will take 1 unit, do what with 2, everybody? Yeah, 192772, you say is times, right? How many minutes pass is how many 2 cm are going to times that it will drop, right? The height. So basically, everybody, you're going to take 40, you're going to minus, this is the hard part, minus 1 unit times 2. That will then give you the height, okay, of A in the N. Everybody can understand what I'm doing or not? Okay, so I'm going to explain again if you all don't understand. Your A, right, started with 40 cm. Then, every minute, the height decreased by 2 cm. If we know that it's 1 unit minute that has passed, so you take 2 cm times 1 unit. Okay, that is how many cm it has dropped. So you take 40 minus how many cm it has dropped. That is the height of A in the N. Okay, now I want you all to focus in your tank B now. It started from a height of 12 cm, which we found just now already, right? So, a height of 12 cm. But remember, for your B, right, water is flowing in. Water is flowing in means your height should be increasing. Okay? Every 1 minute we found out for B, right, the height increased by 1.2. So if it's 1 unit minute, how much will the height increase? What do you do here, everybody? So it's 1 unit times 1.2 cm, and it must be a plus. It must be a plus. Okay, why is it a plus? Because water is flowing in, so your height is increasing, is a plus. Everybody understand or not? This is giving the height of tank B, okay, in the N. Why I equate them to be equal? Because they say the height of the water must be the same. That's why I'm forming this equation. Okay, if you can understand, now I'm going to erase all this so that I can do it. So I have 40 minus 1 unit times 2 is your 2 unit. 1 unit times 1.2 is your 1.2 unit. From here, right, how do you understand this equation? If your math is very good, you know, like bring over all that. Okay, go ahead. But then if you are a bit confused, like don't know what to do, right, I'm going to show you a model that you can understand. So the model, right, I will begin with a 40. So you imagine I draw my model, okay? And that model right here, right, everything here to here it was a 40. What happened is I'm going to minus a 2 unit. So if I minus a 2 unit, I will cut a 2 unit here, right? And then the 2 unit I minus away, I'm going to shade like diagonal lines, okay? Shade away. So after I shade away that 2 unit, I am left with 12 plus 1.2u. So I have left with 12, and then also 1.2 unit, okay? 1.2 unit, okay? I don't have much space, so I'm just going to give it a little bit more space like this. Then you can see a little bit more clearly what you're going to do, right? 1.2 unit plus 2 unit, you will plus. And once you plus already, that value is equals to 40, do what with the 12? Yes, so 40 minus 12, okay? So your 3.2 unit, right, is 40 minus a 12, you'll get a 28. So your 1 unit, right, is a 28 divided by 3.2, and that's how you'll get 8.75. Remember, when you get 1 unit, right, what does it represent? Your 1 unit, you define it as how long it will take for the height to be the same just now. So that also means that when you get your 1 unit, right, you have already gotten the answer. That is the duration. Can you all see or not? Okay, so your final answer here is 8.75 minutes. Okay, 8.75 minutes.